Friends, this question from Quiz2 AI shows an infinite state space is infinite state space search method with a finite branching. So infinite means here the dot represents the infinite. These are infinite. Where S is the start nodes, the second point is S is start node. So you have to start here and reach the goal node, and the third point is G is the goal node. So you have to reach the goal node and start from start node S. This is S, you start here, and G is at the center of the unit circle. This is completely unit circle. Unit circle means they mentioned radius r equal to 1. So that is from G to S the distance is 1. So the radius, these are radius. Unit circle, G is the center of the unit circle and the remaining nodes are on the unit circle. So the remaining nodes S, A1, A2, A3, A4 all are on the unit circle. That is the circumference of this circle. So start from S, A1, A2, A3, A4 and this is a infinite list. A4, A5, A6 and so on. The circular grid is, so generally in the questions we have rectangular grids, right? This one like this. So these are the grids. You have to measure the heuristic distances from the each grid as one unit. Here the circular grid is shown by the dashed lines which are not part of the state space. And the direct edge, so this is the direct edge. This is the direct edge from start node S to goal node G with distance SG equals to 3, right? So given is 3. And these are the edge costs. So SA1. So this is edge cost S to A1 is 1 by 2. And the edge cost A1 to A2 is 1 by 4 and A2 to A3 is 1 by 8 and so on 1 by 6. All these edge costs are, I think edge costs are 1 by 2 power n powers, and take the radial distance as the heuristic value Hg. So that is the heuristic distance from goal node is 0. Hg is 0 and h of S1 is 1 and h of AK equals to 1. These are the heuristic distances. So K from 1 to and so on, that is A1, A2, A3, A4 all these are 1. And then moves and returns the neighbors in alphabetical order. This is the alphabetical order. So A is first, right, in alphabeticals. After this A1, A2, A4 infinite list and G and S goal node and start node. So use alphabetical order to tie breaks. So the sum of, so this is the series, I think it is a series in GP, geometrical progression. So that is sum of 1A square and A cube and so on A power n minus 1, that equals to sum is given by 1 by 1 minus A power n by 1 minus A. This is given in the question. So and the question is, does the BFS breadth first search find the path to the goal? So BFS uses Q, right? Q. This is Q. So works on FIFO, first in first out. So you can remove the elements at this end. Remove or pop, friends. Pop means removing element from the queue. Push, pop, both are functions on the stack and queue. If we add this in this direction, plus add, minus remove, add the elements in this direction. So the right side you are adding, left side removing. You can remember like this. So in 0, right side we are going plus, increasing. Right side is plus, that is so in the number system also, and from the origin you are moving right side, its value is increasing, infinite. In the we are moving left side, its value is decreasing, so minus. So you can remember like this. For the Q, minus means remove, plus means add. Okay, this one easy if you forgot in the exam, otherwise you need to remember all those things. You can directly solve the question. Okay, BFS, there are two lists, right? So open list and closed list. So this is the open list, this one is closed list. First, how you are starting from, in the moveGen also, moveGen table returns the neighbors, right? First you have to start here at the start node. First you have to add the start node to the open node. So open node and explore the start node. So this is the S. So you have to draw the BFS tree or BFS graph, which is useful to find the path easily. So if the SC is explored means circled, it is explored. So explored means write the neighbors of the S. Okay, what are the neighbors of the S? So the neighbors of S are, so S is connected to, this one is S, green color one is connected to A1, next node is A1 and the goal node, right? So A1 and G. So write in alphabetical order, right? A is first, so that is A1 is the children. So neighbors of the S are A1 and G is the goal node. So BFS works on the Q, right? Q. So remove S from the open list and add to the closed list. Why it is explode? If it is explode means we are finding the neighbors. So write the neighbors in alphabetical order in Q. So A1 comma G. This is the open list. So S is removed from the open list and added to the closed list. Okay. So remove from left side, left side and add from right side. So remove from the left side, that is pop. So this side. So just like this is a list. So remove this one. So the pop A1. So pop A1 means, so explode the A1. So and explode the A1 and write the neighbors of A1. So what are the neighbors of A1? Just we are writing the neighbors of A1. So in the graph, the neighbors of A1 are red color one, A2 and this also connected, right? G. A2 only. This is not connected. These are grid lines we use to measure the distances. These dotted lines are used to measure the distances, not the edges. This dark color one are only edges. So the neighbors of A1 is only A2. So only A2. So is this A2 node is added to open list? So it is in the open list. Check if it is in the open list or closed list. If it is in the open list or closed list, before no need to add. Before pop A1 and move A1 to closed list. So S comma A1 are in closed list. So add A2. How you are adding the elements in Q? This is the Q, right? So Q. No need, don't add directly at A1, A2 comma G. Where you have to add the elements right side, right? You add here. Add in this direction. Push. Add or push. That is G comma A2. This is the next open list. So A is already explored and A has a neighbor A2. Okay. So the next element is goal node, right? So pop the goal node. Pop means remove the element. Remove from left side this side. Remove from this left side. G is removed from the open list and added to the closed list. And G is, we have reached the goal node, right? We are starting from here, start node, and reached the goal node. Goal node is find. So no need to, the algorithm stops here, no need to explore the G, and this search function terminates. The program, the entire algorithm terminates successfully. It successfully means it finds the goal node, right? Finally it reach or finds or reach the goal node. So this algorithm is works. So what is the question they are asking? Friends, from this graph, this is the BFS tree. Okay, this is starting from level 0. This is level 1. So level 1 nodes are A1 and G. Level 0 node is S, and level 3 node is L2. Level 2 node is A2. Like this, the tree is growing. So finally we reached the goal node. So how the BFS explored? Level by level. First in the level L0, in the level 0, L0, S is explored. So next, what are the elements in the level 2? A1 and G is, right? First A1 is explored. So that is left to right. So this one from S to A1 and G1. Next it like this. It will reach like this. Explode in this arrow direction. Level by level. So in the question, does the BFS find the path to the goal node? Answer is yes, right? It finds. So what is the path? The path is starting from S, and we have reached the goal node. S to G only, direct path. The path is S comma G, called as depth, right? So depth. So that is depth D equal to 0 here. So there is no children. So S is the root node. Because of this, depth is 0, right? S is the root node, depth is 0. Here the depth D equal to 1 in level 1. Depth D equal to 1. Here the depth D equal to 2. From this question, the goal depth is that is the from starting node to goal node, the depth D is 1, right? So 1 means directly connected by an edge. So direct edge. So directly connected by an edge. So this is visible in this question also. Direct edge from start node S to goal node G. Friends, it is not visible. Okay, S to G. So this is the first point, friends. And the second point is the BFS algorithm is complete. Even the search space is infinite, right? Infinite state space. So they mentioned in the question. So it shows an infinite state space. So the BFS algorithm is complete algorithm on the graphs which having finite branching. Complete means complete. It finally reaches the goal node. It finds the path, friends. This BFS is complete algorithm with a finite branching factors. Complete means it finally reach the goal node. Find the BFS, find the path from starting node to goal node with a finite branching factors is important, friends. Finite branching factors, because it explores the level by level. So that is, it first visited the node at depth D. After it will visit the node at the depth D plus 1. That means first it visited the first level. What are the level 0 nodes? S, right? So first it completes all the nodes at the level 0, and it will go to the next level L1, And what are the nodes? A1 and G are at the level 1 nodes, and it first completes the nodes at A1 from left to right in this direction. A1, next G, goal node. Next it will reach the second level like this. So that is BFS is complete algorithm on graphs with finite branching factors. Friends, thank you for watching. If you like my videos, please like and subscribe my channel and share with your friends.